Company that does not sign on time that drives me out of my freaking. I'm out. So I am Tom Delora. Welcome to the October, I almost said November, ElSIG.
And way to be an engineering leader, Tom.
Yeah, exactly. That is one of the other co-chairs, Ron Lichty. It's been a very busy day. Stand up so we can get a good look at you. Yeah. Thank you very much, Ron.
I've seen his name about a million times on email.
Our other co-chair, Sue, couldn't make it tonight.
Or she may be here late.
Oh, she may be here late. Okay, that's right. Okay.
Maybe here late.
Thank you for coming to this particularly interesting session. First of all, I see a lot of new faces here. Teddy, who knew? Anyone else who knew?
Well, I'm
Very good. How'd you hear about us? How'd you hear about Teddy?
Yes, my name is Teddy Patty. I was invited here by Liz Nevis.
Okay, I like that. That's a cool way to do it. Anyone else? How did you were invited by him?
By Phil?
Yeah, and who invited you?
No, this guy.
I'm a Dan Groupie.
Oh, Dan Groupie. Oh, that's a new one.
Another Dan.
I've heard about, I've heard of Viamita, but never a Dan Groupie. We'll have to make a note of that one. So thank you very much for coming. We always start off with acknowledging our sponsors. First of all, of course, being SAP. Is there no one from SAP here? Yeah, thank you for providing us with this nice facility. Some months we've been having a food and drink sponsor, but right now we're kind of on a hiatus on that. So we're here about working with people about learning what it's like to run teams and everything like that. You know, most people like myself got good at doing something and they said, great, form a team. I'm like, oh, thanks. So that's how I became a manager and then later a director. I'm like, okay, just keep walking forward. But sometimes you need a group like this for people to get together and learn from each other's mistakes and learn from each other's good behavior, a combination of the two. So that's what we're all about tonight. And Sam Hahn, who was part of the group, used to say, jobs last, the relationships last longer than the jobs. And I've always liked that. That's actually very much true. So I think we're going to cut to the chase here real quick. I actually thought we were trading back and forth on this particular topic tonight, what we could do. Dan actually had a nice little Swiss Army knife for topics he could do. Then he happened to mention patents, which is something that's been coming up in my work. A lot of people kind of don't believe in software patents, and I'm like, it doesn't matter. Like the law is the law right now, so you might as well
believe in you.
Yeah, exactly. So this is what the state is. I don't care what you think is right or wrong. We have to obey the law. Now, Dan, and I'm glad I brought my glasses, sent me this bio, and I'm see that. This is called a printout. Now, back in the 90s, you used to do this. Yes, it's paper. And then sometimes you get two of them, right? And you don't swipe it, you staple them. Remarkable. This is really old school. Yeah. It's really kind of cool, though. It's lighter than an iPad. Okay, so I was looking at it. He's got a very impressive employment history, but actually what got me even more was the patents. He got 7 patents already going and some patent pending. I love this patent pending. Gaming team or group affiliation detection utilizing RFID chips. Okay, that's a very interesting one. So basically, Dan has had a lot of experience in this particular field. So I'm looking forward to hearing about what his thoughts are on this area, especially guiding a team, because for a lot of companies, the patents actually is what help the company, create technology and defend it. And so this is kind of a very interesting area. Dan, thank you for coming. Taking care of October. The floor is yours.
Thank you so much. Appreciate that. Yeah, thanks a lot, everyone coming here. Appreciate it a lot. My name is Dan Esbensen. I am the president of Touch Technologies. We've been around since 1982 as a software company, which is a long time for software companies, generally speaking. And we've done that. At first, I thought we were changing our business plan a lot, but it turns out we were pivoting. I just didn't know that's what it was called. So that's what we've been doing for a long time. And a lot of these pivots we've had have been based on patents that we've received. Because when you get certain kinds of patented things, you can start doing certain other things that come from that. All of our patents, by the way, have happened because of a need. We haven't just thought of them and then we did it. A need came up and then we ended up with some patents. We're an unusual company in that we've sold patents for actual money. We've actually made money on patents as opposed to just burning up money doing them. Tell a little bit about my background. First of all, I am an inventor. I'm not an attorney. So all the things I say here about you should really do this and you should really do that, you need to talk to your attorney because they might think, no, don't do that. Don't do those things. Don't do it at all. But these are the things that we did, and we did successfully sell about $22 million worth of patents, which is apparently a lot for, I didn't know it at the time. I thought, well, yeah, sure, they're worth millions. I didn't know that was unusual. I just thought that's just what people did when they had patents. Okay, so patents are a process. When you have a patent, it's some kind of process you're defining, and as a computer programmer, it makes it pretty easy for me because I'm always busy thinking about what, the steps that you take to do something. So it hasn't been too hard for me to come up with steps for doing things, but I know we had at least one client, and I said, okay, write up, what you want your patent to be, and they sent me a capabilities list. It was just a list of things that they could do, but it had nothing to do with the steps of transforming this kind of input into that kind of output. And that's kind of patents have to transform something. I think that's one of the tests for them, is you have to transform something. And that's what a patent is. And a patent's not just a list of sort of things that you do. The other thing that's very important with patents is that you can write up what you think a patent is, and which I've done quite a few, and then you give it to your patent attorney, and when they're done, they're very difficult to recognize because what they have to write up is a thing called patentees, that's what I call it, and every single word gets looked at if there's some kind of lawsuit or something, okay? If there's some kind of challenge to your patent, every little word is looked at very, very carefully. And they have all these things that can occur to your patent. One thing is called a Markman hearing, by the way. A Markman hearing is something where they constrain the words. I mean, you wrote these words that said, and the system will do this, and the output will do that. Then they'll constrain the word system to mean something probably different than what you thought, and they'll constrain output to mean something very, very specific. And it's a very complex thing that my patent attorney deals with. So I very strongly recommend that if you write up some patent things, you use a patent attorney and they do the final thing on it, okay? So that's like really important. All right, there are design patents and there are utility patents. I only attempted to do one design patent. A design patent is kind of like a copyright, where what you're doing is that you are, you're kind of describing a general sort of thing, like an example. The one I'll tell you the one I tried to do. The one I wanted to do was, it occurred to me one day when I was driving, I had sunglasses on, not these, I was driving like this, and I was driving across Nevada, and long drive, and I can't stand like glasses, and so my nose was hurting and stuff, and these glasses were wraparound glasses, so they wrapped around my head like this. They were like called clicks. Anyone seen those ever? Anyway, as I leaned back, the glasses rose up like this, and now my nose didn't hurt. I thought, wow, wouldn't that be a cool design patent? I could make a general design for anything that lifted up your glasses a little bit, and then make my fortune that way, which didn't work out. It turned out someone else had thought of that 10 years earlier, so couldn't get that. All right, so we already had a little bit of discussion here too, which we'll talk about our software patents. There's a lot of controversy about them. The very first patent that I ever had, by the way, was in 1989, and back in 89, you had to write your patents for software as if they were hardware. You had to mention switches and registers and all kinds of things that when I got that patent back, I was like, what the world is this? I couldn't figure out what anything meant because it was all about a mechanism that you would design and not an actual piece of software that would process something. And that would change. I think the challenge was like in 1995 or something like that. That all changed. And patents then became like real things again. And now I think there's some new constraining things to that just happened, last year or something, or some changes in that. But we'll get some more on that. I'm going to tell you some patent stories. Every one of our patents has kind of a cool story because we didn't just do it. We actually were in a situation, and that's how the patent came up. Those tend to be good patents. Well, for us, they've been good because they actually have a use. One thing you should keep in mind is that you can patent things that cannot be built currently. Okay, at all. Like that's called embodiment. If you have a patent and you describe the whole thing, okay, that's a patent. It doesn't have to work in terms of, is it possible to build it? An example is that I know a guy who had a really cool patent. If you know how microwaves work for transmitting energy, you have a big microwave here. You can send energy between the two at 98% efficiency. Right? That's how microwave transmission of energy works. This guy said, what if the antennas were the size of photons? What if we made the antennas that small? Then those antennas would resonate to a photon, and you could get 98% efficiency of transferring, light and photons into energy. And he got a patent on that, even though to this day there's no way to manufacture such a thing. But he absolutely got a patent on it, even though you can't build it. So you can patent things that can't be built. So he did that for other reasons. He thought he could build it. Okay, and then we're going to talk a little bit about how you mine for patents. That's what I call it. So if you're busy working, and you've got your team of people, how you can kind of get them alert for what kinds of things might be patentable that they're doing. And one thing I should tell you also, I am a strong advocate that you do not have your engineering team see if what they're currently doing is against someone else's patent, okay? Because that'll keep them very, very busy doing that. Plus, if you say it's corporate policy, that you always make sure that all of your software has been checked against literally millions of patents. And then it's found that you have a policy of that. And then it's found that later that you violated a patent. Okay, that's willful violation. And you can be in real, real big trouble. It's like triple damage or something. It's really, really bad. So we recommend that the times you look to patent something are when you've exhausted, you've thought of something unique, something really cool. You already tried to find various software libraries that did it. I'm talking about software again. Software libraries that did it. You've asked all your friends who are smart, have they ever seen this before? And at the end of all that, if no one's thought of it and you've got a lot of good, smart friends, then you look at applying for a patent. And we'll talk about prior art issues in a minute as well. All right. Okay, I've been programming since 1968. So a pretty long time. That was back when computers were very, very large and very, very slow relative to today. We thought they were fast. They were so much faster than Addy machines. It was amazing. We really liked them. Started developing commercial software in 1974. Co-founded Touch Technologies in '82. Remember, still in business all this time. We were actually 4 of us who were founders. And 3 of the founders are still with the company. The 4th one passed away, but she would have been here otherwise, I'm sure. First invention was in 1989. And that was a really cool invention, which we're going to talk about in a little bit. I have about 12 plus patents, including pending, that are out there. And really what stops you from doing more usually is just money. It's not that you don't think, once you get in the mode, you kind of do it. And Steve and I just had a brainstorming session a couple weeks ago where we did what's called a 5-year visualization, where you move ahead 5 years and then you start thinking about what exists then. And then you build patents for 5 years from now. Okay. That does become important because usually your patents don't get granted for about 3 to 4 years after you've applied for one. There's a thing called fast track. We'll talk about that. Okay, I have a couple famous patents, but most of my patents are obscure. Usually patents are really weird. You'll say, I got a patent on whatever. And you look it up, and it is so obscure. You're like, yeah, okay. Who would ever do that? But they have a patent, and it's cool they got one, and it's nice to have their name on it. And we have some of those too. I'm not going to be showing you too many of those. They're kind of not exciting. But we did them. Okay, and currently we're growing our company, Touch Technologies, from what's been a tech lab for the last 10 years into a technology portfolio company. We discovered that we can really unlock a lot of our technology. We're about 10 years ahead on a lot of our stuff. So at least it was at the time. So we're kind of ready now to do some pretty exciting things. We can get some of that later on. Okay, our company's founded in '82, San Diego, plus we have a Silicon Valley presence, 32 years, California C Corporation. We've got a bunch of cool stuff. We have what's called a reusable code base, which means that whenever our engineers had to build anything, even internal, like our internal GL, they had to write it as if it was a product that was going to be shrink wrapped. We required that, and that way they have reusable libraries and things. And they hated that, but now we're 30 years into it, and we have a ton of stuff that's really nice because of that. They did a thing called documentation. I don't know if you've heard of that. It's an old style method, but they did a lot of that. All right, this is one of the first cool patents that we got called variable cache memory. And this one was built because we had some clients that had a problem and that they were trying to back up data from their disk drives to their tape drives. And the way that tape drives worked back then, those big 9-track tapes, is that they go zip, zip, zip. They're going like this, flip-flopping back and forth. And the reason they did that is that once the tape started, it really didn't want to stop because it built up speed. And once it stopped, it kind of skidded to a stop, and then it had to back up again. And so all those movies you see where you see these tapes going back and forth, that was the bad thing happening to the tapes. It wasn't the good thing happening. That's because they didn't have a steady data rate. So we thought of a really cool way to do a steady data rate. And this particular patent ended up, sorry, I hit that thing. This particular patent ended up being part of a bidding war between 2 major tape companies and sold for many millions of dollars. And that's pretty much it. The abstract Wasn't very much, it wasn't a big deal. But it was a core piece, and no one had thought of that kind of idea. Virtual memory was really, really new back then, and we thought of a really cool way to do it. And it was out of a need again. Okay, this one here, automated network surveillance. Anyone heard of the stuff with Snowden and everything, where the NSA has been snooping all the stuff? Okay, this is the patent that we built, which that stuff's built on. Okay, we didn't build any other technology whatsoever. 0, 0, 0. Okay, but this is what we did back. The priority date's 96. We of course started it earlier than that, much earlier than that, as trade secret and all the other things you have to do. To make sure that you don't get in trouble with the one-year statutes and blah, blah, blah. But we had a priority date of 1996 on it. The NSA was doing this stuff really early on. This was done as a project that we did for the Department of Energy. That's how we got involved in this. We sold this off for millions of dollars to another company, a different company, not the NSA. They just take things. They don't have to do that. Yeah.
So if the NSA is doing something secretly before you, does that count as?
No. Prior art, if it's a secret organization, it's not prior art. So you can tap into things that you can get a patent on that they were already doing. Yeah, absolutely. Yeah, absolutely. And what this patent had to do with, by the way, was scalability. People have been doing network surveillance for a long time prior to this, but we figured out how to do it with millions and millions and millions of systems simultaneously on a 200 megahertz box back then. So that was one of our big breakthrough things. And this was our next one. If anyone's seen the TV show Person of Interest, or one of those things where there's cameras everywhere, or the movie Enemy of the State, blah, blah, blah. Okay. This was the core patent for being able to do that kind of data. Again, this was a core thing for data rates. The question is, how do you get that much data simultaneously into your servers to then make sense out of all of it? So this wasn't the actual, gee, I know it's you and I see your face. Nothing to do with that. This had to do with the low level. How do you handle data rates that are that fast? And this one got sold for, actually this one was here, we got a little ripped off on this one, I felt a little bit. We sold this one not for millions, sadly, and we got a royalty stream. Royalty stream, I thought, cool, royalty, you get 20 years on your patents. A 20-year royalty stream on this really cool idea. We're gonna make a fortune, okay? Well, it turns out that royalty is kind of defined the same way it is in Hollywood movies, where they subtract all kinds of stuff from what they're doing, and somehow over each of these years, they always end up using all this money to market this thing. And this last year, we got our first royalty check. I mean, that actually exceeded the amount of all of their marketing efforts, apparently, to license this patent, and that was for $500. So, and that was after, I don't know, 7 years or something like that of time. So I wouldn't recommend doing royalties deals if you're selling your patents. I think cash, much better. So we didn't know that back then, we just had no idea that's how that worked. This is one of our more obscure ones. This is obscure, but I'll tell you why I have it on here. This is a thing for converting binary numbers to character codes, and it's a pretty simple idea. You just have, you have binary data in some computer register thing, and you want to make 407, but you want it to be the digit 4, the digit 0, and the digit 7 as characters, like ASCII characters. And the question is, how do you do that really, really, really fast? And this patent talked about how to do that, using a special data type that we invented. And then this ended up being the data type that we invented. And this was a data type that had to do, it's really simple. It was a data type, which people do nowadays, I'm sure. But it is a data type that had to do with where the fractional part and the integer part were in two separate memory locations, completely separate memory locations. And if they're in separate memory locations, you can do a lot of magical tricks on them, including converting them from, of course, binary data to character data. And that was the big deal on it. Funny story on this, at the time I had thought of this idea, actually I was in my patent attorney's office and I had already talked to him about some stuff, and he was like, what else you got? And I thought, well, I don't know. And he's like, well, if you can give me one more patent, he said, you'd be an inventor. Ooh, an inventor? I thought it'd be so cool to be an inventor, I already had 3, apparently 4 must be the magic number because I had 3 prior, so and I'd be an inventor, right? So we just did this one, and it cost about $10,000 to do this one. Everything, including all the stuff happening, about $10,000, which I guess was a good deal. And we had the money, and so we did it. And so later on, when we were looking at selling patents, by the way, we're happy to sell them because we license, I'll talk about that later more, but we license back the use of them unlimited for our own private use, but we sell the patent. So we keep the technology, we keep the license, but we sell the patent. And so we wanted to do that, and they're like, well, what can we get for this? So our broker, because at the time we weren't brokering, we're doing brokering now, but back then we weren't brokering. And they said, well, you know, what else you got? And I said, well, we got this thing here. And they said, well, how much money would you want for it? I said, you know what, if we got 10,000 out of it, because that's what we put into it, I'd be happy enough, because that way, you know, I kind of felt bad about I did it just for pure ego, which I did, right? You know, that was the only reason I did it, you know. So if we got our 10,000 back, I wouldn't feel as guilty, you know, we could just do it. And there was a bidding war between Intel and Microsoft, I think, on that one. And so it went up, 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 up. And so that became a very profitable one, so that was nice. So that was that patent. All right, and then this one here, see, this one got granted, is that last year? No, last year, I think, maybe. Last year, year before. Priority date's 2009, but I think it might have been last year before. This had to do with the faster way to do what's called base 64 encoding. That's how attachments work. You know, if you have an attachment, it converts to a MIME type thing and blah, blah, blah. And we figured out a really, really, really slick way to do that. And that was the fastest patent that we ever sold. That one was granted in like, I guess that day, May 4th, and I think we had it sold by July 1st. It was a really, really fast, really, really fast sale. So that was pretty cool. Oh, and by the way, and this was because of a client. We had a client, and I had to do base 64 encoding. Let me tell you the story again. Okay, we had a client in base 64 encoding, and they're like, can you do it for us? And so I went, you know, there's tons of libraries out there, by the way, that do base 64 encode and decode. You can get a ton of them out there. And so I got a library, and I could do the call, and I say, yeah, I can do it. I can do, you know, 13 million, you know, characters per second. And the guy's like, is that all? He said, we have lots of